Hi guys, today we are going to talk about measurements and accuracy and precision. The first one we're going to talk about is accuracy and precision. As you can see on the screen here, we have some dartboards. So when something is accurate means that you have hit your target. So for your playing darts, you'll notice your target is the center of the board. So the one on the right-hand side, that is considered to be accurate because all of yours are hit your target. Whereas the one in the middle is not accurate, even though they're all clumped together, but you have not hit your target. That one is actually considered to be precise. Precise is when all your measurements are all very close to each other. So in the middle, every single time I threw my darts, you'll notice that they are all clumped together. So that is precise, but it is not accurate because it has not hit my target. Okay. So most of the time when something is accurate, it is also precise, like the one over all the way to the right. Whereas the one all the way to the left, whereas you were all over the place, that is both inaccurate and imprecise. Okay, so when we take our measurements, we want to be both accurate and precise. When we take multiple trials, which is why we take multiple trials, we want to be as close to possible each other. They may not be exactly the same every single time, and that is fine because just like when we threw that dartboard, we were not at the exact same spot every single time, but we were close enough. They were very, very accurate in that respect. Now, when we measure things, we also have to be accurate in terms of what we are measuring. So if we look at this block right here, what do you think the measurement would be? So the way that we measure something is we first record the numbers that we are absolutely positively certain of. So we know this measurement is definitely 1, okay, because it's past here. So you'll notice then these tick marks here, this is what we refer to as tick marks. Each one of those tick marks would be 0.1. So this would be right here would be 1.1, 1.2, 1.3. But notice how, if I change the color here, if I go right here at the edge of mine, it's not quite 1.4. So I am certain that this is at least 1.3. But it's a little bit more than 1.3, right? So that last number that we put is always an estimate. So we're going to say 1.35 because it's about halfway in between. So the first numbers that you have are always the ones that you are absolutely positively certain of. That last number in the measurement is always an estimate. Okay, and most of the time when we estimate, it's either like 0 or 0.5 because we're not quite sure what it is. Okay, so let's go to another one. So let's take a look at this one. So if you look at these two beakers, you will actually notice a few things. Number one, the one on the left, or the one on the right, sorry, has a lot more tick marks than the other. So let's take a look and figure out what our units would be and what our measurements would be for both of these graduated cylinders. So we're going to label this as number 1 and number 2. So go ahead, take a look at it, and what would the measurement be for graduated cylinder number 1? So the thing we need to remember is always record first the ones that you are certain of. So I know absolutely certain that this is 4 milliliters. Since there are no other tick marks, this next measurement is our estimated measurement. So it's more than 0.5, so maybe 0.8. So this would be 4.8 milliliters. Knowing that we are certain it is definitely 4 milliliters, but this next one, it could be 0.8, it could be 0.5, or it really could be 0.9. We just don't know. It's an estimate. So now take a look at graduated cylinder number 2. What would the measurement be for graduated cylinder number 2? So again, what are my certain numbers? I know it's definitely 4. This time we have tick marks. So that would be 1, 2, 3, 4, 5, 6. Wait, did I do that right? 4.1, 2, 3, 4, 5, 6, 7. So it's definitely 4.7. And then that next one would be my estimate. So this would be 4.7. I don't know, we can say 1. I could say 0. I could say 2. That last number is always an estimate. So as you can see, this one, we have a few more numbers than the 4.8. Okay. Whenever we measure things, we can only measure out to a certain degree based on the measuring tool that we use. So when I ask you to measure certain graduated cylinders, we have a few graduated cylinders that have more tick marks than others. You want to make sure you're choosing the correct tool to get you the best measurement possible. Okay. So let's do a few more. And you're not probably used to doing this. You just kind of look at your ruler and just kind of say, okay, this is what it is. Okay, but we want to make sure that we are measuring to the best degree as we can. Okay. So let's try another. So how about this one? What would the length of that line be? So in here, we know my measurement is definitely 1. So we are certain it's 1 point. And let's see, my tick lines, this is 0.1, 0.2. We are absolutely certain that the length of this line is 1.2. Now that last number we estimate. So I'd probably say 1.25. Okay. Let's try one more. And this does make a difference when we start measuring things. A lot of times our rulers have even millimeters in it. Okay. I know I'm showing you inches. Most of the time we do not measure in inches in chemistry class. And how about this one? What would the length of this line be? We are absolutely certain that it's 1 point and then the estimate, 0. Now, at 1.0, are we certain it's 1.0? Yes, we are certain it's 1.0, okay, because it's right on this line. So now it's really 1.00 in that case. We just need to make sure when we are measuring to the best of our ability in those, whatever tool that we are given. What about this one?